Hello everyone. As part of learning big data with Hadoop and Spark, we have already seen about the storage component, that is HDFS, and the distributed processing component, that is MapReduce. Now we shall see the resource management component, YARN. Now what exactly is YARN? The abbreviation goes like yet another resource negotiator, and this is the cluster resource management system when we are working with Hadoop, and YARN started coming into picture from Hadoop 2 version onwards. Till Hadoop 1 versions, we do not have a separate component called YARN. Everything was taken care by Hadoop 1. There is no discussion on YARN. So it started coming into picture from Hadoop 2 onwards, and it provides APIs for requesting the resources, using the resources, and like what are the resources? Just like when we deal with operating system, the major resources will be storage, CPU time or the processor time, and so on. So here also we are IO devices and so on. So here also we will be talking about when we are trying to execute a distributed process, how the resources are allocated, how the application place request for resources, how resources are allocated by the distributed system, and so on. So who is taking care of handling the resource requests under Hadoop distributed environment? It is YARN, yet another resource negotiator. Now whenever we are trying to work with the YARN application, it comes with two long running daemons. First one is the resource manager and the second one is the node manager. What is the resource manager? It will be a process or a daemon which runs one per cluster. There will be only one resource manager daemon which will be running one per cluster, and it will manage the usage of all the resources across the cluster. And node managers, they will be running on each and every node in the cluster. Say for example, I have 50 nodes in my cluster, I will have 50 node managers, just for example. So similarly, for the entire cluster of 50 nodes, there will be one resource manager, right? Then resource manager, which will manage all the resources of the cluster, node manager, which runs on each and every node, and those node managers will be launching and monitoring the containers. What is a container? It is like an area where an application should run, right? So if you try to see, a container executes an application specific process with constrained set of resources. So it is you can think of, it's a memory space, address space, where specific resources are allocated and the application has to execute in that particular user area. So depending on how YARN is configured, container can be a Unix process or a Linux C group, stands for control group. Now the following figure, if you see how the YARN runs an application, try to remember this diagram. I will show the steps, what is 1, what is 2A, what is 2B, what is 3 and what is 4. 4A and 4B. I will talk about these steps. Now let us try to understand, whenever the client submits an application on the node or on a node where he is working, the submitted application goes to the resource manager, because every application needs some resources. So first of all, the resource manager takes the application whichever is submitted, and it will find out one node manager which can try to execute the application. So it will ask the node manager, through all these devices will be communicating via heartbeats only, small messages, wherein the resource manager talks to the node manager asking for, can you run this specific application? If the node manager responds with a yes, a container will be launched onto the node manager, and this node manager will go through execution of the application. If the node manager can finish the execution with the available resources with single container, it will proceed and submits the answer. On the other hand, if this node manager feels requirement for splitting the application into multiple tasks and requesting the services of other node managers, each one can run a specific task if that is required, then this node manager will again send a request to the resource manager, sorry, I am all alone, cannot execute this one, please give me some more node managers and containers. Then the resource manager will give more number of containers where the specific tasks of the entire application will be executed. This is how yarn will execute. I will show the steps theoretically. To run an application on yarn, a client contacts the resource manager and asks it to run an application. Under steps 2A, 2B, what is happening? The resource manager finds a node manager and launches a container. Step 3, try to understand what the application master does once it is running depends on the application. It could simply run a computation in the container it is running in and return the result to the client, or it could request more containers from the resource manager. This is try to understand whenever I give you some work. If at all it is a simple work or a small work, the single person will be finishing that work and gives me the result. Suppose the task is big, what I will say, you can share or you can take help of your friends, finish the task and give me the result. In that case, what do you say? Sorry ma'am, I cannot do all alone, let me share the work with my friends. So, the first node manager is telling the resource manager, I cannot process this task all alone, I need more containers. So, each container will be launched onto different nodes and all of them will work together. So, once I get all the multiple containers, we are using them in a distributed computation. Now, in any of the cases, none of the devices will talk to each other. See, node managers, even though 5 node managers are executing my application, all of them will not communicate with one another. Any communication should happen via the resource manager. And some advanced layers have come wherein remote procedure calls are being allowed. Now, how they request for resources? Generally, whenever we learn operating system concepts, we talk about resource allocation, resource request, all these concepts. So, these concepts are little similar to that. Let us try to understand. Yarn has a flexible model for making resource request. Whenever you are requesting the request for set of containers, this can be expressed the amount of computer required for each container. We generally, if I say I want 5 containers, how the request is to be placed? In each container, how much memory is needed, what is the CPU processing you are trying to have. So, you are trying to specify for every container what are the requirements of memory, what are the requirements from the processor, as well as you are also specifying locality containers. Locality constraints for the container. What do we mean by locality constraints? Whenever we are working with locality, this is very critical when I am working in a network environment, because suppose I am running on machine A and I want to access the resources which are there in the network on machine B. I need some bandwidth. So, in a network environment, bandwidth is the costliest resource. So, locality plays a very important role. If I am running on machine A, whatever I require to run this application, if everything is available in the same machine, I do not need to use a network bandwidth. So, I say I am running with locality optimization. On the other hand, for everything I need to request the network, then I am the costliest application wherein using too much of the bandwidth from the network. So, locality is very critical when we are working with distributed processing algorithms, because they are using cluster bandwidth and we want to have an efficient usage of cluster bandwidth. So, yarn allows an application to specify locality constraints for the containers. Locality constraints, it can be used to request a container on a specific node or a rack or anywhere on the cluster, that is off rack. What do I mean by this? Say for example, I want to run an application, and in that application I want to use, say for example, there is a file my resume, right? I can request the yarn stating please give me the node where I can run my application, and if at all possible there will be 3 copies of every block. If possible, try to allocate me the node where this resume file is maintained, right? If I get that, I can finish off my work because the data is available in that machine, right? Or you can also ask for on rack, or if nothing is available we go for off rack. So sometimes the locality constraint cannot be met, in which case either no allocation is made or optionally the constraint can be loosened. Say for example, you are very particular about, you want a node where the data is available. In such case, suppose that node is free, it will allocate. If the node is not free, then you will not allocate. Yarn will say sorry, that node is busy. In such case, it is up to the application or the client who can decide whether you are okay to run it on any other node or you want to wait for that node, right? For example, if a specific node was requested but it is not possible to start a container on it, then yarn will try to start a container on a node in the same rack means the same network cluster, or if that is not possible, on any node in the cluster, somewhere anywhere. I told you the other day what do we mean by locality optimization, local machine, on rack, off rack. Local machine, the application, data both are on the same system. On rack, say for example, I am trying to execute an application in a lab. Data is available in the same network of the institution, on rack. I am running an application on a node, but data is available somewhere in the other part of the world, off rack, right? So where you want to have the resource. In the common case of launching a container to process HDFS block, the application will request for a container on one of the nodes hosting the block's 3 replicas. As I told, for every block you will have 3 replicas. So ideally we request for please allocate any one of these 3 nodes so that my application can finish off fast. And a yarn application can make resource requests at any time while it is running. There are 2 types of requesting the resources. One is static requirement, the other one is dynamic resource request. What do you mean by static requirement or static resource request? Before actually using all the resources, I will say I need 5 IO devices, I need this much memory space. Whether you use it or not, beforehand you place a request for all the resources, which may be advantageous because you are having all the resources at your hand, your application need not wait. On the disadvantage part, until you complete the application, you may not release the resources, wherein other applications will be waiting for these resources, and at your place you may not use all the resources at the same instance of time, stagnation of the idle resources. So there is a trade-off. So a yarn application allows you to go for both static resource request as well as dynamic resource request. On the go, first I will start with minimal set of resources. As I proceed, I might go for requesting other resources as and when the requirement comes. So for example, Spark goes with the first approach, that is the static resource request model, and MapReduce goes with dynamic resource request model. How do we justify MapReduce is going for dynamic resource request? First, the driver routine has to run. Until that, map method will not use any resources. So only whatever resources are needed for the driver routine, those will be allocated. Once the driver routine wants to pass on the control to the map method, then whatever resources are needed for the map function, those will be allocated. Until map finishes, reducer will not work. So, the reducer resource requests are allocated when the reducer actually starts execution. That is how we go for dynamic resource request model. What is the lifespan of an application? Sometimes some of the applications can finish within fractions of second, some can take days, and some applications can run for months of time. Now, what does he say is, why should I look for lifespan of an application when I want to grant the resource request? Let me look for categorizing the applications. Say for example, shall I allow at a point one application per user job? Shall I allow that, or shall I go for one application per workflow? That means 5 to 6 users are working at the same instance of time. Shall I count all these people as one application? Or first method is one user, one application. Second one application per workflow. At this instance of time, how many users are submitting an application execution? Shall I count all of them as one application? The other one, third model is long running application which is shared by different users. We do not mind who is submitting an application at what time. Can I consider in 1 week how many users have submitted application as one application? How do I want to consider, right? So, such an application often acts in some kind of coordination role. So, there are various components of Hadoop framework which are trying to categorize the applications based on how they are considered than what is the lifespan of them. And how do we build yarn applications? So many things are possible. Either you can start building an application from the scratch, or we can use an existing yarn model in order to run the current application model. So, various models have been listed out here. Now, this is very important. Yarn, we know it started from Hadoop 2, and the first version is called as MapReduce 1. So, what is the differences between these two? Who is advantageous? Who is a less advantageous one? We cannot say disadvantageous. Who is having a less advantageous? Now, the distributed implementation of MapReduce in the original version is initially called as MapReduce 1 to distinguish it from MapReduce 2, which has a separate component called yarn. Now, MapReduce 1, there are two types of daemons. First one is controlling the job execution process, which we call as the job tracker, and multiple task trackers used to be there. What do we mean by job tracker and task tracker? Say for example, I want to take care of student admission, for example, and the tasks involved in this is fill the application and pay the fees, take your admit card. 3 processes, try to understand. The entire job is student admission process, right? And this job is split into 3 tasks. For the entire admission process, one job tracker will be there. For individual tasks, you will have a task manager. So, in Hadoop 1 model, we used to have a job tracker, one or more task trackers, and the job tracker was coordinating all the jobs which are running on the system by scheduling algorithms and all. And what are the task trackers doing? They were running the tasks and they used to send the progress report to the job tracker. And if any time a task fails, what is the job tracker will do? It reschedules it on another node. So, in MapReduce 1, job tracker was taking care of both job scheduling and progress and monitoring. On the other hand, from Hadoop to or MapReduce to, Yarn is taking care of all these things of allocation, monitoring, progress and all. So, if you try to summarize, in MapReduce 1, job tracker is there to take care of the entire job, task tracker will execute only a specific task, and there is something called as slot, where the area or the memory space where the user application is running. The same thing when you go for MapReduce 2, the resource manager is there which will take care of allocating the resources, taking care of resource requests, all these things. Application master will monitor the entire application, and a timeline server will monitor the progress of the application, or it will at least record the progress of the application. Instead of task tracker, here we are calling them as node manager. Instead of slot, we are calling them as containers here. So, Yarn was designed to address many limitations of MapReduce 1. What are the benefits of introducing Yarn here? It supports many workflows including MapReduce. We call it as multi-tenancy. At the same instance of time, multiple applications can run simultaneously. Suppose one user is working with a mapper, the other user's reducer can run, the other user can start with the driver, just taking example. So, multiple applications can be submitted at the same instance of time. We call it as multi-tenancy. Similarly, scaling has become very easy compared to earlier version, and high availability compared to MapReduce 1, Yarn is giving more availability, and utilization of the resources is also optimized. Apart from this, so many other advantages are found. It increased the agility of the application execution and so on. So, in the next class we will be talking about the scheduling algorithms of Yarn. So far I just introduced what are the resource requests, how the resources are allocated, what is Yarn providing as some advantages, etc. So, in the next one we will be talking about scheduling of the resources.